take this sequence as an example. We've got series rather, 1 over 6, 1 over 12, 1 over 24, and so on. All right. Now, what type of series is this? Is it an arithmetic or geometric? Right? Remember, every time you come across a sequence or series and you want to find out if they don't tell you in the exam if it's arithmetic or geometric, you always test. And the first thing to test for is arithmetic. What you're going to do first is you're going to decide if they're adding the same number or subtracting the same number between successive terms. That is, for them to move from this term, they add the same number for, as in when they move from this term to that term, as in when they move from this term to that term. That's the first thing you need to sort of check, right? So how do we check that? If you want to know what they added onto 1 over 3 to get 1 over 6, you just simply go the next number, which is 1 over 6, minus the previous number, which is 1 over 3. This gives us an answer of 6, 1 minus 2 minus 1 over 6, right? So that's what they added onto 1 over 3 in order for them to get 1 over 6. Now, if you want to find out what they added onto 1 over 6 to get 1 over 12, you just go 1 over 12, that's the next number, minus the previous, minus 1 over 6. This will give us 12 over minus, it'll give us minus 1 over, it'll give us minus 1 over 12. Okay, let's see if I did the calculations correct just quickly. That gives me, yes, 2. Yeah, it gives us minus 1 over 12. Now, do you see that they didn't add, or rather you could say subtract, they didn't add or subtract the same number between successive terms. So then you know that this is not an arithmetic series. So then you obviously test for others. But remember, you guys, you're only expected to know the arithmetic series and the geometric series. So therefore, the next thing to check for is the geometric, it being a geometric series, all right? So remember, that is the one where they multiply the same number between like successive terms, all right? So how do we check for that? You want to know what number they multiplied onto the 1 over 3 to get 1 over 6? You just simply go the next number, divide by the previous. So it's 1 over 6, divide by 1 over 3. This will give us an answer of 1 over 2. Let's do the same there. If we go the next number, divide by the previous, we're checking if this thing is a constant ratio. It also gives us 1 over 2. This will also give us 1 over 2 as well. So therefore, we can safely conclude that this is a geometric series. Why? Because we are multiplying the same number between successive terms. Are we all happy with those assertions? Yeah? So now, remember, what are we doing? We're doing the so-called sum to infinity, and I emphasize in the introduction that it falls under the geometric series, right? You'll see shortly why I say that. Now, let us find let's write it on the side. Let us find S3 for this specific series. S3 just means the sum of the first 3 terms. You're basically saying T1 plus T2 plus T3. You are adding the first 3, all right? That's what it means. So in this specific example, we have 1 over 3 plus 1 over 6 plus 1 over 12. This gives us how much? You guys remember, you need to punch as fast on your calculator as in when you chat on WhatsApp in the late hours, please. 7 over 12. Okay, let's express it as a decimal to 4 decimal places. 0. Let's make it 2. 0.5, no, 4. 5833. Okay, 30 keeps on recurring. Chap, that's the answer we get, right? Let us say S10. Can we find S10? Ne? Okay, let's make it S6. Ne? So obviously we have to add the first six terms of the sequence, or the series rather. That is T1 plus T2 plus T3 plus T4 plus T5 plus T6. Right? Sharp. You need to add all of them. But it also looks like it's going to take a bit of time. You can go ahead and do it, but we could rather use the formula for the sum of a geometric series, since we've already established that it is a geometric series, all right? Remember, there's 2 formulae. you can choose from. There's this Sn equals a r to the power n minus 1 in brackets over r minus 1. You apply this when your r is greater than 1. That is when your constant ratio is like a number that is above 1. Okay. So the second formula or option would be a open bracket 1 minus r to the power n close bracket all over 1 minus r. Okay, you can use one of the two. You only use this when your r is less than 1. All right, it's a fraction or anything of that sort, but it's less than 1. Okay, not necessarily always a fraction, but with the numbers less than 1. So since our ratio for this example is less than 1, we can then use the second formula. All right, let us go. S6, we're looking for S6, right? Remember, A represents the first term. So what is the first term in this, series? It's 1 over 3. 1 minus, what is our ratio? Our ratio is 1 over 2. To avoid punching too much, just make it 0.5 because 1 over 2 is 0.5. Then our n is like 3, 6. Close over 1 minus 0.5. If you're smart enough, you realize this is 1 minus a half, so it should give you a half. You're going to save time for you to punch quicker. Okay? Who's that? Who's that? Wait. Who's that? The person whose background is playing. Kanya, please. Kanya, please. So remember, you guys have to substitute here. Let's go. Substitute quick. You guys remember, I have to be fast. Are. Anyone to finish within the next 10 seconds, please? I'd appreciate it. Finish that within the next 10 seconds. I'm waiting for the answer. S6. Anyone? Anyone? S6? Anyone? S6? Let's go. Mpho, let's go. Hlale. Khwathile. Shezi. Khatego. 0.66. Yes. Yes. Yes, you guys, we're all on the same wavelength. So it's yes. As a fraction is that, as a decimal is 0.66, right? If you make it to 4 decimal places, because this is what you get on your calculator. If you make it to 4 decimal places, we normally do the 2, but I just want to make it 4 for the purpose of this this concept, sum to infinity. Okay. This is what the answer 6563, yes, to 4 decimal places. Sharp. Remember S3, what did we get for S3? We got 0. Let's go up. 0.58 5833. Okay. Now, you guys, please don't what do you call it? Do not cancel out what you already typed on your calculator. I want us to find S10. Can you go to Can you find S10? You just simply use the arrows to arrow to your calculator. Instead of 6, you put a 10. Yeah, 6. Yeah, 6, 0, 1, like that. 0, 2, whatever. Can you guys find me S11? Or rather S13. Find S13 for me. Remember, you just use the arrows to sort of toggle through the entries there on your calculator. What is S13? Yes. Okay. I'm waiting for everybody else in the class to make sure that they all got the same answer. Please show a thumbs up quickly if you are good. If you got the same. Just want to make sure that we're all in the same boat. Yes. Proper stuff. Let's go S16. Can someone do me S16? Let's all do it. Same, ne? Same. But it's slightly more than the previous one. Agree? This one is 6, 6, 6, 3, 3 sixes and a 5. This one says 4 sixes and a 5 after. Let's try S20. All of us. And let us talk just to make sure that we're good. We're all good. S620. Yes, so it's how many sixes? 1, 2, 3, 4, 5, 6 sixes. What a coincidence, my. Something like this. I get. So you guys see that the higher you go. Remember, we started at S3, right? We calculated S3. We got 0.58, and then we went ahead and went S6. We got 0.6563, and then we just jumped to S10. We got 0.66 with a 0.2 there. We went to S13. It's almost the same, but slightly more. 16, almost the same, slightly higher, not more. And S20, slightly higher, more. So if you keep on going up, if you go S50, it's gonna get to a point where you're gonna go S50, S51, S52, S53. You're gonna get the same answer. Look at this. Can you guys put F50 there? Go find S50 for me. Let's go. S50. I think someone typed. Let me quickly check. Apologies for seeing this late. Oh my word. Very important. Say I don't know if it's a problem on my end, but I can't see the screen. Okay. I'm gonna unshare the screen and reshare the screen for Kanya, Shezi, because Kanya says she can't see the screen. But I think it's a problem on Kanya's side because who else can't see the screen? Wait, who else can't see the screen? Just want to make sure that Kanya's good. Shezi. So everybody else can see the screen. All right. Okanya's gonna log out and back in. Then yeah, log out Kanya and back in so that you, or rather move to a place where you know it's got the best network coverage. Okay, Kanya, are you good now? Yeah. All right, proper stuff. Sharp. So you guys, I asked you to find me S650. Sorry, did you find it? What is the answer? Yeah, 0.66. It keeps on going, ne? That it's basically 2/3, ne? Yes. Can you get me S? Can you do me S100 now? S100. Same, ne? 0.6. So now, yeah, it's 2/3, ne? So the answers are now the same. Now, this is what we call the sum to infinity, ne? If you keep on, there's a specific like group of arithmetic series examples, ne? Like arithmetic series, where the higher the n, when you calculate Sn, it gets to a point where the answer will not change, will be the same. We call that conversion. Conversion means gets very close to. So as n increases, as the n increases, it becomes higher and higher. Your series will converge to a certain number. So this specific series converges to 2/3, 0.666. It converges, never crosses. It gets to a point where it never crosses as n increases. So this is what we call to sum to infinity. That is, even if you go to infinity and go S1,000 for this, or S1,000,000 for this specific series, sorry, it will still be 2/3, sum to infinity. Delicious, bro. Are you